Welcome to putting the derivative rules together. So at this point, we have seen quite a few derivative rules, and we're going to go ahead and work with them all mixed together. So for our first example, find the derivative of f of x equals, in the numerator, x squared times cosine of x, all divided by x plus 1. So we have f prime of x is equal to the very sort of last operation we did here would have been the division. So we're going to treat this as a quotient rule problem. So we're going to use the quotient rule first. What the quotient rule says we should do is we should take the derivative of the first. So we're going to do the derivative of x squared cosine of x times the bottom, so times x plus 1. Then to that we will add the first, so x squared cosine of x times the derivative of the second, x plus 1. Sorry, we don't add, we subtract for the quotient rule. So we'll subtract. Again, I just changed it to subtraction. The quotient rule, we always subtract. And then we are dividing by the second, x plus 1, that whole thing squared. So I've left the things I still have to differentiate in purple. So at this point, that first derivative has a product involved. So we are going to use the product rule to go from here to our next step. So we have this is equal to, the product rule says that we do the derivative of the first. We'll do the derivative of x squared times the second, so times cosine of x, plus the first, x squared times the derivative of the second, so times the derivative of cosine of x. This entire thing was multiplying our x plus 1. I clearly did not give myself enough room here. Then we have our subtracting x squared cosine of x. I'm going to leave that derivative of x plus 1 for the moment. And all of that is dividing or divided by x plus 1 squared. At this point, we can go ahead and take our derivatives. So we're going to use the power rule. And trig derivatives. And we wind up with f prime of x is equal to, the derivative of x squared by the power rule is 2x, then cosine x. The derivative of cosine x is negative sine x, so this will become minus x squared times sine of x. All of that is multiplied by x plus 1. And then we are subtracting off x squared cosine of x. Let me give myself a little more room quickly. All right, so we are subtracting off x squared cosine of x times the derivative of x plus 1 is just 1 all over x plus 1 squared, or in other words, we have that this is all equal to 2x cosine x minus x squared sine of x times x plus 1 minus x squared cosine of x all over x plus 1 squared. Now we could multiply out the stuff on the numerator that requires multiplication, do a little bit of combining like terms, but I'm going to stop at this point. So again, this is sort of a non-simplified version of the derivative, but it is the full derivative. We don't have any more differentiation steps left. Now for another example, let's go ahead and find the derivative. G of x equals 3x to the 4th cotangent of x minus 7x to the negative 5th cosecant x. So to find this derivative, g prime of x will be equal to 3 times the derivative of x to the 4th cotangent of x, and then minus 7 times the derivative of x to the negative 5th cosecant of x. And then from here, we have two products, so we are going to need to use the product rule. And the product rule, so we have our 3 times. Product rule says that we do the derivative of the first, so the derivative of x to the 4th times times cotangent of x plus the first x to the 4th times the derivative of cotangent of x. And then from here, we subtract 7 times we do the derivative of the first, so the derivative of x to the negative 5th times the second cosecant x plus the first x to the negative 5th times the derivative of the second, so times the derivative of cosecant x. At this point, we're just going to use our various derivative rules. Right? So we have both power rule and trig derivatives. And so we have 3 times the derivative of x to the 4th. Power rule says that's 4x cubed, and times cotangent of x. Then we have plus x to the 4th times the derivative of cotangent of x is negative cosecant squared of x. Then we are subtracting 7 times the derivative of x to the negative fifth is negative 5x to the negative sixth by our power rule. Then we have times cosecant of x. Then we have plus x to the negative fifth. The derivative of cosecant x is negative cosecant x times cotangent of x. And then if we just do a little simplification, excuse me, we do a little simplification, this becomes 12x cubed cotangent of x plus, minus 3x to the fourth cosecant squared of x plus 35x to the negative sixth cosecant of x. And then we have plus 7x to the negative fifth cosecant of x cotangent of x. Right, so that was just distributing in the 3 and the negative 7. So this is using multiple derivative rules kind of mixed together. As you get faster and more comfortable with derivatives, you may not need to write out the intermediary steps where I say what derivative is next. But particularly when we have lots of rules involved mixed together, this is a way just to kind of keep track of where you are at in the problem. So anyways, that's using multiple derivative rules all mixed together.